Hello, my name is Tyrell. I have worked as a software engineer and solutions consultant for about 5 years and have studied computer science and mathematics for about 16 years. I have built a demonstration application for this video. I thought it would be fun and beneficial to fulfill a new requirement for it live. This is to demonstrate both my software and consulting skills at once, as well as to introduce you to my refined consulting workflow and recommended software architecture. Without further ado, let us begin. Before I demonstrate the mock application and fulfill a live requirement, I would like to share some wisdom from my years in consulting and development. This should be helpful for you regardless of whether or not you hire me. In a simplistic view, there are two layers to software, the domain layer and the application layer. The domain layer houses what is called your business logic. It is your database and all the logic therein. Domain or business logic is any logic that applies to data in all applications. For example, in logistics, when a purchase order is received by a warehouse, the inventory for its line items is increased. So the domain layer houses both the data and the universal rules that apply to that data. The application layer houses the user interfaces and processes that allow human beings to interact with the domain. Continuing with our warehouse example, a warehouse manager would have an application that he or she logs into that allows him to create purchase orders and receive them. Software architecture is the manner in which these two layers are brought together, both conceptually in how they are viewed and practically in how the components work together at the level of computer code. There are two patterns or architecture types I would like to show you. The first pattern is each application having its own domain layer. This is very common in the industry today. WordPress has this architecture, as well as many other commonly used platforms. Any third-party solution you use, such as Salesforce, will force you into this architecture because their domain layer is coupled to their application layer. Basically, each application has its own domain. Integration between platforms and third-party solutions requires the internal domains to speak to each other through APIs. As you can see, the system as a whole becomes enormously complex as more and more components are added. All these systems are maintained separately. If a new domain rule is made, it must be replicated on each application's individual domain layer. Scalability is also extremely difficult as each individual application must be scaled out separately. The second pattern is that there is one domain layer and all applications talk to that one domain layer. This offers many advantages over the former architecture. For scalability, the application layer scales extremely easily as there is only HTML, CSS, and JavaScript and requires no server-side processing. This means that you can serve them from a service like Amazon S3 and further scale them with a content delivery network with ease. This leaves only the domain layer to scale, which can also easily be done with a master-slave database relationship and load balancing. Basically, with this architecture, you can go from 0 to thousands of requests a second without much technical work. In addition, changes to domain logic only need to be made in one place, as the application layers are now completely decoupled from the domain layer. Finally, new applications can be added without increasing the complexity of the system. In systems engineering, complexity is a liability that almost always results in calamities. That is why we say in the business, follow the KISS principle, KISS standing for Keep It Simple, Stupid. As such, I would highly recommend a decoupled domain architecture. Next, I will share for you some wisdom on the consulting and development workflow. The basic flow begins with requirements elicitation. In this stage, the product is brought from a solution-minded concept to a clearly defined definition of what will be built. Once this is complete, the engineers will develop the solution defined. Then the software solution is launched and the users are trained on how to use it. After they have used it for a while, they will often have ideas for improvements as well as new feature requests. These new requirements are then elicited, and the cycle continues. There are two ways in which this cycle is executed in my experience. The release cycle can be monolithic or micro in nature. In a monolithic release cycle, a large vision of all needed features is attempted to be conceived up front, whereas in a micro release cycle, the initial requirements are of a more narrow scope. It seeks to only solve a few problems at a time and keeps its solutions simplistic and practical in nature. Monolithic release cycles are much less effective in all stages. In the requirements elicitation stage, too much is being discussed at once, which leads to vague definitions. These vague definitions lead to guesswork in the development phase, which leads to more rework. In the implementation and training phase, there is too much to take in, which causes user frustration. This causes the feedback to be negative and non-constructive. The opposite is true in a micro-release cycle. Because of the narrow scope, great detail can be amassed in the requirements phase. With these clear definitions, the developers can accurately create the vision. The user base will be much happier to leverage a simple and relevant solution set, which results in much better feedback. This is why I highly recommend a micro-release cycle. Now I will show you a mock application I built with a decoupled domain architecture. This is 3PL. It is a logistics system for a small warehouse. Note the clever use of backwards E's as a marketing ploy. This is what happens when developers attempt branding. Anyway, I digress. Following with our micro-release cycle, we began with a small yet relevant and useful solution set for the warehouse's operations. This system tracks purchase orders and provides inventory levels on a per SKU basis. For those who are unfamiliar with logistics, a SKU is a unique identifier for products. As you can see, I have two columns of programs running. Each column has a terminal at the bottom for executing the programs, a text editor above for making changes to the source code, and a browser at the top for testing and demonstration purposes. The left column houses the domain layer. If we go to the browser, you can see that we can make web requests to get data from the server in what is called JSON notation. Right now there are two endpoints, one for SKUs and one for purchase orders. This is just data and obviously isn't very useful for human beings, which brings us to the application layer. The warehouse application has four views. It has a SKUs index page, which lists all SKUs in the system and their inventory levels, both in table form and as a bar graph. This data was all generated using a library to create mock data. It's called the Faker Gym, and they have a good sense of humor, which is why I like them. I really gotta get me some rustic paper keyboards. Then there is the purchase order index, which lists all purchase orders on a calendar and as a list. Next, there is the purchase order show view, which shows the purchase order in the form of an invoice. Finally, there is a form view to edit each purchase order. So if we go back to the SKU section, we can see that there are some products that are out of stock. Those sleek linen pants are flying off the shelf and they're having a hard time keeping up with inventory. Let's go ahead and order some more. First, we will create a new purchase order. Then we will add a new line item for the sleek leather pants. Now let's check our stock. Oh, we haven't got them in yet. That's because the PO hasn't been received yet. So let's say some time has passed and mark the PO as received. Now let's check the SKUs index. There we go. We have 100 inventory. Okay, so like I said, it is a very simple application. It works though, and because they are in a micro-release cycle, they're implementing it with ease and have some user feedback. They like to keep the SKUs index page up on a large terminal in the warehouse so they can see all the stock levels. Currently they have to refresh the browser every time there's an update, and they were wondering if it were possible to avoid this. We drafted up a new requirement where the data for the SKUs index would be automatically updated every second without a page refresh. Not the most impressive requirement ever, but I don't want to make you watch me code for hours either. So let's go ahead and develop this new feature. So this is the file that drives the application logic. It handles everything from changing the view to getting the data from the domain. And this is the SKUs index logic. This initialize function here executes when you load the SKUs index page. And this line right here is where we load the data from the server into the view. I'm going to leverage a built-in callback function. And this is to create a checksum, which is like a signature, and it'll allow us to tell if there's new data or not. We want to do this because we don't want to re-render it every time. Only if there's new data. We're going to use an MD5 hashing algorithm to create the checksum. And now that we have that, we can tell if the data is new or not. Next, we're going to use JavaScript's setInterval. This allows us to fire something every so often, in this case 1 second. What we're going to execute here is basically the same thing, only slightly modified. We don't want to put the collection on this because this has changed because we're inside a new function. So instead we're going to put it on self, which is why we define that up here. And then we also want to create a new checksum to compare against the old one. Now, if the new data checksum is different or does not equal, then we know that we have new data. Thusly, we need to re-render the view and set the data checksum to the new one. And finally, we're going to execute this every 1,000 milliseconds or 1 second. And this should fulfill the new requirement. Okay, so let's go ahead and make sure that we have fulfilled the new requirement. First thing we're going to do is reload the application into the browser. Now take note that the first SKU is Awesome Iron Gloves. Now we're going to load new data into the database, and we should expect to see that this view updates without a page refresh. In order to load the new data, we're going to execute this script. The script uses the faker gem I was talking about before, and it's going to create a new set of purchase order and SKUs. So we're going to run the script and watch the browser, and it works. We now have a complete new set of data, and we did it without a page refresh. So the requirement is fulfilled and the client is happy. That's it for my introduction video. Thank you very much for your time. I hope my wisdom as a software engineer and consultant will aid you in your project. I am very passionate about solving real-world problems and would love to bring your vision to life. The source code for the Diml application is in the GitHub link below. I wrote all the content for this video and did the production myself, save for the icons which were provided by FlatIcon. Best of luck on your project. I hope to hear from you soon, and have a wonderful day.